Uh, my name is Susumu Yamazaki, an associate professor at the University of Kitakyushu. One of my current research interests focus on system and social implementation using Elixir. I'm a co-founder and creator of pyramid trees and satellite image processing systems with Elixir. First, I talk motivation of my talk. When implementing a system that requires performance, we sometimes use NIFs, a mechanism for calling higher performance C code from Elixir. NIFs perform better than port, another mechanism to call C. Port launches an OS processes whose program code may be written in C. It is safer than NIFs because it is protected under the control of OS. But however, they have the disadvantage that if they crash, the entire ARM VM will be abnormally terminated, even under supervisor control. A supervisor is a process which supervises other processes, which we refer to as a child process. Supervisors are used to build a hierarchical process structure called a supervision tree. Supervision trees provide fault-tolerant and encapsulate how our applications start and shut down. This is from hex docs of supervisor. This defect is a significant obstacle when building fault-tolerant systems. Here is from the chapter 2, the 7 myths of ARM performance of efficiency guide users guide. Rewriting ARM code to a NIF to make it faster should be seen as a last resort. It is only granted to be dangerous, but not granted to speed up the program. How should we do? This talk shows 3 points to describe robustness. The first tip: appropriately set a conditional branch where each function call may return an uncertain value. An example code. This is bad example code. The function foo assumes to return a pointer when it usually finishes, but to return null when it fails. When consider a situation to call the function bar with the return value of foo, the figure on the right shows code sample that causes a problem. Why? Because this code will abort due to a segmentation fault when foo returns null. The function foo assumes to return a pointer when it usually finishes, but to return null when it fails. So if there is this code in NIFs, even if a supervisor monitors the Elixir process that calls the NIFs, this fault will make the for VM that executes the process abort. In this case, we should describe as the code in the figure on the right. The first tip: appropriate set a conditional branch where each function call may return uncertain value. Because foo may return an uncertain value, including null, when we should set the return value foo to a temporal variable w. Judge whether w is null or not with a conditional branch. If W is null, this indicates the fact foo aborted. Then we should rescue this. In this example, throw an exception to Elixir by enif make badwag. Otherwise, call bar with W to set V. Enif make badwag is an if function to throw an argument error exception to Elixir to be returned from an if. Then, again, appropriately set a conditional branch where each function call may return an uncertain value. The second tip. Perform error handling according to a general convention. General convention of error handling in Elixir from error handling in Elixir school. For errors that are part of the regular operation of a function returns tuple of OK and result, and error and reason accordingly. For errors that are not part of normal operations, you throw an exception. NIFs should also follow this. An example code. For errors that are part of the regular operation of function, the function should return OK and result as a figure on the right in this case, in case that it finishes normally. Here is a tuple, and here is atom, OK, and result. For errors that are part of the regular operation of function, the function should return the error and reason as the figure on the right in case that an error occurred. Here is a reason. This is made by enif make string and return tuples, atom, and reason. Fill the reason of the error in the string. Describe the reason of error here. Elixir will receive error and reason, but note that char list describes the reason of error here instead of an ordinary string describes the reason of error here will be stored in reason. Of course, you can get an ordinary string instead of char list as a reason, but the code will be more complex, so I recommend to write as the code to get char list. For errors that are not part of normal operations, the function should throw an exception. You can use argument error exception by enif badwag as a figure of the right. In Elixir, argument error occurs. The function should throw an exception. You can also throw Erlang error with reason by enif raise exception as the figure on the right. Enif make string, describe reason here, and enif raise exception. Fill the reason of the error in the string. In Elixir, Erlang error describe reason here. Note that char list instead of an ordinary string will be stored in reason. Elixir will receive error and reason, but not the char list instead of an ordinary string. And also, note that char list instead of an ordinary string will be stored in the reason. So, if needed, convert the char list in the reason to an ordinary string as the code in the figure on the right. Here is Elixir code. Here is calling NIF function. Here is OK result. And here is error and reason. Reason is converted to list to by list to string. Here is an argument error case and Alan error case. Alan, if Alan, in case of Alan error, the message will converted to list to string. The second tip again, perform error handling according to general conventions. Then the third tip, make assertion that specify implicit precondition and raise exceptions for supervisor to handle. Using assertion is able to make the program aborted when getting unintentional input or output to prevent bringing disruptive fault. The function squared in the figure on the right compute the square root of the input of A. Because the square root of a negative value is an imaginary number, the function squared gives an error. So when given an intentional input of A, that is a negative value, we should use assertion to make the program aborted. In this case, assert A is greater or equals 0 ensures that the variable after the assertion is 0 or positive value. Though this assert is the function used in an ordinary C program, let's see how to assert a precondition in NIFs in the following slides. Here is assertion is in NIFs. In NIF, instead of using assert.a header, write a conditional branch that negates the assert condition and raise an exception as introduced the second tip when the assert condition is violated. Here is the value. If getting value is getting value false, make raise bad arg exception. Here is a assertion. If A is greater than or equals to 0, the reason not A is greater than and equals to 0. Here make reason by inif make string and raise exception Alan error exception. If assert is true, inif make value double makes the result. The figure on the right shows a part of calculation of the square root of in NIFs. In the case of an ordinary C program, assertion makes the program abort only. In the case of Elixir and NIFs, the combination of assertion and supervisors makes the program abort when unintentional input or output, relaunch it and receive another input. Supervisor in Elixir brings more practical use case of assertion. Then the third tip again. Make assertions that specify implicit preconditions and raise exceptions for supervisor to handle. Okay, we understand how to describe robust NIFs. But how should we apply this method to existing libraries? If we cannot modify them or need to modify them too much, we should consider choosing ports instead of NIFs. Okay, here's the summary. NIFs have the disadvantage that if they crash, the entire RMVM will abnormally terminate, even under supervisor's control. This talk shows 3 points to describe robust NIFs. Appropriately set a conditional branch where each function call may return an uncertain value. Perform error handling according to general conventions, and make assertions that specify implicit preconditions and raise exceptions for supervisor to handle. However, if you use existing libraries to apply this method and cannot modify them or need to modify them too much, you should consider choosing ports instead of NIFs. Thank you.
Thank you, Susumu, for the presentation. I think we have a few minutes for questions. So if you have any questions, please use the Q&A tab in Huva. I can already see there was one question in the Huva. I think it's already answered, but maybe we can explain it out loud for everyone. So the question was, is there a specific reason to go with C instead of Rust in terms of robustness, perhaps? This question.
Oh, of course, Rust is a good solution. The reason is simply that I introduce a traditional approach. So I recommend to use Rust, but this presentation just show using C approach.